Hello dear aspirants, this is Dr. Sourav Sir's classes. Our contact number is 98367 93076. Again, I am repeating our contact number, which is 98367 93076. And our email ID is souravsirclasses@gmail.com. So if you have any mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number or you can WhatsApp also. Rather, you can drop an email to our email ID. Then you can join as a student to our institute and you can join our regular batches, our one-on-one sessions and our online classes, so that will be beneficial for your preparation of upcoming examinations like CUET PG Statistics. So please feel free to uh, ask us if you have any question. Okay, so now we are going to solve a problem which is appeared in the CUET PG Statistics, and the question is telling us that limit n extends to infinity. Sorry, that is a typo. That will be limit n tends to infinity 1 by n, in the second bracket 1 plus 2 to the power half 3 to the power 1 by 3 and n to the power 1 by n is equals to, there are four options here which are 0, 1, 3 and infinity. So this is a very quite easy question. So how can we solve that? So we are tasked with evaluating the limit n tends to infinity. Let me write it in the whiteboard. Limit n tends to infinity, and that will be 1 by n into, we are getting 2 and 3 to the power 1 by 3 plus 4 to the power 1 by 4 up to, we are going to n to the power 1 by n. Okay, so this is the limit of the average of the sequence k raised to the power 1 divided by k for k is equals to 1, 2 up to n. And to evaluate this limit, and we are and to evaluate this limit, we analyze the behavior of k to the power 1 by k as k tends to infinity. So now we are going to analyze the k to the power 1 by k as k tends to infinity. Okay, so this function k to the power 1 by k can be rewritten using exponential and logarithms. So our k to the k raised to the power 1 by k will be, that will be equals to e to the power ln k upon k. That means whole ln k upon k. Okay, so as k tends to infinity, our this part, that means ln k upon k will go to where? That will go to 0. So then our e to the power 0 will be this k to the power 1 by k, so that will be 1. So thus our k to the power 1 by k converges to 1 as k tends to infinity. Okay, so now we are going to evaluate the limit of the average. So the limit are evaluating, so the limit we are evaluating is limit n tends to infinity 1 upon n, and that will be I to n k to the power 1 by k. So that means the average of this thing. So finally we will get what? So finally we are getting that since our k to the power 1 by k is goes to 1 as k tends to infinity, so the terms in the sum is summation I equals to 1 to n. Sorry, that will be k. Then it's, sorry, that's a typo. K equals to 1 to n, k to the power 1 by k are dominated by values close to 1 for large. So the average of these terms will also converge to 1. So now we are going to give the formal justification. So to rigorously justify, we justify this, we use the fact that if a sequence AK converges to L, let me AK, let us take converging to L. Okay, so now we can write that then the average of the first n terms of the sequence also converges to L, that is limit n tends to infinity 1 upon n summation k equals to 1 up to n a k. That has to be what? That has to be also L. So hence our ak is equals to k to the power 1 by k, and L is 1, as our this is what? This is this, and this is 1. So we can write that our limit n tends to infinity. Sorry, limit n tends to infinity, k to the power 1 upon k will be equals to 1. Sorry, I want to write this thing. Yeah, this is equals to 1. So the final answer will be the limit of this thing is our 1. So again, I am telling that if you have any other mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number, or you can WhatsApp. Also, rather you can drop an email to our email ID, which is sourceclasses@gmail.com. Then you can join as a student to our institute, and you can enjoy all the services of Dr. Sourab's classes. Okay, thank you guys. So thank you guys. Hope you understood. Thank you.